The topic is MetaOpenfoam and LLM-based multi-agent framework for CFD. Welcome. Please start.
Okay. Good afternoon, everyone. My name is Chen Yuxuan from Tsinghua University, and I'll give my presentation on MetaOpenfoam, a large language model-based multi-agent framework for CFD. And I will show my. In this presentation, we will cover the research background, introduce MetaOpenfoam, describe our experiments, and conclude with our future plan. And at first, what CFD simulation are done with manual code. If I want to change some condition, I need to change the source code. After that, for convenience, some files that need to be modified are extracted as input files, and finally become the button tab simulation through GUI. And this evolution made simulation more user-friendly, leading to the development of popular industrial software like Fluent and so on. And despite the advancement, button type simulation are still not friendly for freshmen, because they do not know what kind of button they should be clicked and what kind of button should not be clicked. So MetaOpenfoam aims to revolutionize this by introducing language type simulation, where users can describe their requirements in natural language, and the agents will handle the rest, which make CFD simulation more accessible and efficient. If I want to develop language-type CFD simulation methods, we need to find a tool to link different large language models. And here we introduce MetaGPT, which assign different roles to GPTs to form a software company for complex tasks. Such as in this software company, every GPT has its role, like product manager, which gave requirement document to architect, and architect design system to the product manager, and so on. And so what is product manager mean? It's a role. Then what's a role? In a multi-agent system, each agent acts like a digital organism with its environment, which contains a large language model to observe, think, action, and memory. A multi-agent system can be thought as a society of agents working together in an environment. So they follow standard operating procedures, communicate and operate within an economy system to achieve tasks efficiently. And with MetaGPT, next we will introduce MetaOpenfoam. MetaOpenfoam contains 4 roles, and the procedure of MetaOpenfoam is: first, architect take the user requirements and split into several subtasks and give it into input writer. And then input writer to write input or rewrite input from files and give it to the runner. And then the runner run OpenFOAM and give the error information to reviewer if the error exists. And then the reviewer review the file architecture and file context to solve this run error and return back to the input writer. And that's repeat the loop until there is no error occur. So in this procedure, some database like OpenFOAM tutorial will be used to improve the performance of MetaOpenfoam. In a summary, MetaOpenfoam automates CFD simulation by solve this error. So how does the database be used to improve the performance of MetaOpenfoam? That's retrieval augmented generation, which we use non-chain to realize it. And first, we have tutorial documents, and then we split into several chunks, and we restore every chunk into vector store. And when user gave his requirement, it will do a research similarity search, and we found a similar case and put them into the prompts and give the prompt to the large language model and wait him for response. And RAG enhance the agent's ability to perform their tasks and ensure that the framework can handle a wide range of CFD simulations. And then I will introduce my experiments. First, in our first experiment, we conducted a DNS simulation of incompressible forcing homogeneous isentropic turbulence with grade 13 to the third power grade using DNSFoam. The architect converts the user requirement to the standard format with case name, case domain, and so on. And then they will find the most similar case to this requirement, which will use RAG. And then we create a new architecture according to this similar case and split into several tasks. Like in this case, they split into 9 subtasks, and line 1 to write an OpenFoam momentum transport from file in constant floater, blah blah, and subtask 9 to write an OpenFoam block mesh dict from file. And then the input writer will write or rewrite input forms based on the subtasks from architect and reviewer, ensuring that all input files are correctly prepared for the simulation. And the runner will write and run the simulation comments, return errors to reviewer, and the reviewer will analyze the error. If the error is related to the file structure, the reviewer will update the file structure. And if the error is related to some file context, it will generate the rewrite tasks to the input writer. And that makes a loop named loop 1. And in this loop, reviewer found an error no label patch provided is due to block mesh dict in system floater and need to rewrite. And the input writer rewrite the boundary to solve this error. But is the error really solved? The answer is yes, but the old error no neighbor patch provided has been solved, but the new one cannot find patch field entry for something comes, and that makes loop 2. And in this loop, review found that the velocity in 0 floater needs to be rewritten. And after rewriting, running OpenFoam, runner run OpenFoam, and we get the results of DNS HIT. So this simple example demonstrated the feasibility of MetaOpenfoam. And then we use 3 different user requirements to test MetaOpenfoam with 3 different turbulent models, DNS, LES, and RANS. And with 3 different flow conditions, HIT, channel flow, and backward facing step. They were all successfully run by 2 loops, 6 loops, and 12 loops. So the generalization of MetaOpenfoam is also demonstrated. And here we change the key data of user requirement, like grid size from 13.2 to 16. And let's say what MetaOpenfoam perform, and we can find that the input of block mesh dict was successfully changed from 13.2 to 16. So it verifies that MetaOpenfoam can identify the change of key data. And for the randomness, which is very important in large language model, and the randomness parameter temperature results in is very important and affects the generated test diversity. We know the low temperature results in a more stable and consistent outputs, like when temperature is equal to 0.01. I test 3 times and got both, and the number of loops is all 6, while high temperature would even be an infinite loop, like temperature is equal to 0.5 or 0.99. The number of loops will exist in infinite loop. So in my test, all temperature of a large language model is 0.01, which is not enough to set 0. And for completeness, it performs a similar behavior like GPT. The more you describe, the more probability you may get the successful simulation. And in the first case, I describe as much as possible. And in the second case, I miss the grid size, which needs two loops in simulation. And in the third case, the user requirement is very simple without any description, so the number of loop is infinite. So here we load the more completeness the next loop times MetaOpenfoam is. And in the last, human participation in agents decision-making process can also be realized to enhance the system performance. Like some complex geometric configuration, you can provide the block mesh dict file by yourself. It is unknown. And so that for conclusion, the basic framework of MetaOpenfoam is implemented, and tests have shown that MetaOpenfoam have ability to automate CFD simulation, only use natural language as input, and also can achieve desired simulation. And for the future plan, which is very important, and we are going to maybe to do the following things. First is geometric or parameter optimization based on large language model. And there is also very important, we need a more larger and comprehensive OpenFOAM tutorial database, not only for RAG, but also for fine-tuning. And 3, fine-tuning is also very important, but it needs a lot of GPU training resources. And the last source code will be open source as soon as possible. That's all. Thank you.
Okay, thank you for your talk. Any questions from the audience?
It's a very interesting work.
Yeah.
Can you explain a little bit more about the database you are using currently for the agent?
Okay. The appendix I show some of my database, such as I use split symbol to divide them, and with case begin, case name something, and blah blah blah, and case input name, case input folder, and so that's a case without input file. And the input file I put on another database, for different large language model, such as you can see this picture, and I show the case OpenFOAM case. That is what I have shown. It will be used to create input architecture, and for the OpenFOAM tutorials, it concludes some input files, and we will use to write input phone files, and yeah, oh, okay, and another we have OpenFOAM comments, which we use to write all-round file. Yeah, these are database, and all the database I use is from OpenFOAM 10 tutorials, and I translate to the pan text. Yeah, thank you.
Any other questions?
Is there any expert knowledge integrated in this workflow, such as you have the first layer of Y+ thickness in your block mesh dict, or like the CFL number is less than 1 if you are going to set your time step?
I didn't test it, but if the database has this information, I believe it could also success. Yeah.
Okay, thank you.
Thank you for your presentation. I'm wondering that is that large language models have the ability to understand how to build a very complex geometry mesh. In your demo, you just build some simple geometry mesh, but I'm curious that it might be impossible for describe a complex geometry by a natural language.
Yeah, you're right. It's very hard to for us to build a very complex geometric. So the human edit is also possible. If the block mesh dict is very complex, we can write by our human self. Yeah.
Thank you very much.
Thanks for your presentation. Question can be simple. So in your slides, you just mentioned a cavity case, right?
Yeah.
And all of your work are based on cavity cases. So I think that in the future time, you can provide more case.
Okay.
So in that situation, your tool or your framework can be more powerful, right?
Yeah.
Okay.
Yeah. In the future, I will test more cases. The 3 case is only in the beginning.
Yeah. Okay. Thank you.